will use LabVIEW to connect to non-NI instruments and validate the results. In this lesson, we will use LabVIEW to connect to non-NI instruments and validate the results. Suppose you have a standalone instrument from a non-NI vendor, such as Tektronix or Keysight Technologies. You can control and automate the instrument using LabVIEW. LabVIEW can automate instrument-based processes and consolidate multiple instruments into one development environment. A basic instrument control system consists of a non-NI instrument, hardware connectivity, and a computer. Instruments from non-NI vendors include amplifiers, analyzers, calibrators, oscilloscopes, power supplies, switches, function generators, and more. Hardware connectivity refers to the physical cable connecting the instrument and also the communication protocol or bus. Common bus types include Gpib, serial, USB, and Ethernet. Different buses have different capabilities for latency and bandwidth. Instruments often have multiple ports for hardware connectivity options. Finally, you can use LabVIEW software on your computer to acquire, analyze, and visualize data from your instruments and to automate and control your instruments. First, install. Let's look at how LabVIEW help automate an instrument control application. Suppose you need to determine the cutoff frequency of an RC circuit by sending the RC circuit a frequency sweep of 100 different sine wave frequencies, 1 Hz to 100 Hz. To do this, you must input sine waves of frequencies between 1 Hz and 100 Hz to the RC circuit and analyze the output response signals. The function generator sends these stimulus signals to the RC circuit, and the oscilloscope acquires the RC circuit response signals. To do this manually, your steps might look something like this: long and involved, with a large amount of repetition and increased chance for human error. If you programmatically control your function generator and oscilloscope, you can automate many of these manual steps. This saves an enormous amount of time and decreases the chance for human error. First, install LabVIEW. Then install any required NI hardware drivers. You must install the NI Visa driver. If you are trying to communicate with a non-NI instrument using Gpib connectivity, then you must install the NI 488.2 driver, which automatically installs the NI Visa driver also. Next, connect the non-NI instrument to the computer. For example, if you are using a Gpib instrument, then you need a Gpib instrument control device on your computer, such as a USB Gpib HS device or PCI Gpib device. Connect the Gpib instrument control device to your computer, and then use a Gpib cable to connect the Gpib instrument control device to your instruments. If you are using a serial instrument, then connect the serial port on your computer to the instrument with a serial cable. In this example, I have a 34411A digital multimeter instrument made by Agilent or Keysight. Looking at its rear panel, we see that this instrument has interfaces for a Gpib, USB, or Ethernet bus. For this example, I will connect this instrument to a Gpib cable. Now, I will attach this Gpib instrument control device to my computer. Now, I can connect my Gpib instrument to my computer. After connecting your non-NI instrument to your computer, if you have a Gpib, serial, or Ethernet instrument, you will need to configure your instrument in Imax. Launch Imax. Now, I'll walk you through how to configure a Gpib instrument in Imax. Expand Devices and Interfaces. Click the Gpib instrument control device icon, and then click the Scan for Instruments button, which returns all the Gpib instruments connected to your Gpib instrument control device. On the Properties tab, notice that the default name for the instrument is based on a string containing the Gpib board number, primary address, and instrument. You can set a Visa alias for the instrument. so you can identify the instrument more easily in LabVIEW. Next, you should find and install the specific instrument driver for your non-NI instrument. To do this, launch the NI Package Manager and search for the instrument driver for your instrument. Follow the prompts to install the instrument driver. You can also search for instruments by vendor and model number. After configuring your instrument in Imax and installing an instrument driver, find its example programs in the Help, Find Examples in Browse tab under Hardware Input and Output. Navigate to Instrument Drivers, LabVIEW Plug and Play, and now we see our specific instruments examples here. Now I can select the example program that is closest to what I want to do with the instrument and run it to validate that the instrument is returning the expected results. Here I have an example for Agilent 34401. Let's open the Acquire and Graph Software Triggered VI. In this case, I'm using my 34401A instrument to measure the resistance of a 100 ohm resistor with a tolerance of plus or minus 5%. So I'll set the VISA resource name to my 34401A Gpib instrument and set the function to the measurement that I want to take, which is a 2-wire resistance. Now I'll click the Run button to run this example program. It is now sending 5 software triggers to the instrument that acquire 10 samples each and will return the measurement samples on this graph. And now I've validated that the instrument is returning my expected result of 100 ohms plus or minus 5%. If no instrument driver exists for your non-NI instrument, you will need to communicate with the instrument using Skippy Commands. Skippy stands for Standard Commands for Programmable Instrumentation. In this example, the computer sends a *IDN Skippy command to the instrument, which asks the instrument to identify itself. The instrument responds to this command by returning a company name, model number, serial number, firmware revision, string. Refer to your instrument's manual to determine which Skippy commands work with your instrument. To validate your instrument input or output results, you can use Skippy Commands. Launch Imax and then click on your instrument, and click the Open VISA Test Panel tab. In the VISA Test Panel, go to Input-Output and then enter your Skippy command. The Write button writes the Skippy command to the instrument. The Read button reads data from the instrument. The Query button writes the Skippy command to the instrument and then immediately reads data from the instrument. As an example, I'm going to do a query on my instrument with the *IDN command. This Skippy command returns its make and model number. Now I'll do a query with the measure resistance Skippy command. This returns a resistance measurement from the instrument. For some instrument buses, such as serial, you might need to add a termination character, such as a /n line feed character, at the end of your Skippy command to communicate properly. First, double-check any cable connections. Second, verify that the First, double-check any cable connections. Second, verify that the non-NI instruments show up in Imax successfully. Third, refer to your non-NI instruments manual. You've completed this module. Here is a summary of what you've learned.